Hey, for this troubleshooting video today, we're going to be going through a sample lab scenario with the ASA 5505, where traffic from these clients on the outside through a router here, which is like an internet router, right, is going through a 3-interface firewall. Inside, outside, and DMZ are the interfaces, and then we're trying to reach a web server at 10.3.6.50 on the inside interface. So let's pretend we've got users complaining they can't reach the web server or access is intermittent to the web server, and this is the problem we're troubleshooting. So if I am actually on the outside of this ASA, so if I try to load the web server at 10.3.6.50 and I inspect my browser here, this is Chrome, I can see that the access is pending and I can't load the page, or it loads really slowly. So this is the issue that we're troubleshooting today. So we're going to go through some of the techniques that we could use to diagnose this problem and try to get it solved. So we've got our outside, inside, and DMZ. We know the traffic should be going from the outside to the inside based on this diagram. So right away we can sort of almost eliminate the DMZ and not focus so much on it at the start, because that's important to do when you have a firewall with many interfaces. You know, if you've got a firewall with 50 named interfaces, it's tough to troubleshoot all of those interfaces at once. So what we'll do first is just narrow down on those two. So this is the ASA. It's an ASA 5505 running version 9.1.2. It's an older version in the 9X train, but all the tools that we use here are certainly applicable to later versions and earlier versions of the ASA software. So let's take a look. Some of the first things people do when they're troubleshooting is they'll do a show memory, you know, and you can see that there's lots of free memory there. Okay, so that's not a problem. Next they'll think, oh, maybe their CPU is high, so show CPU usage, and we can see it's at 19%. That's not a lot, I guess. So at this point, things look okay. What do you do next? Well, unfortunately, a lot of times we see ASA administrators or router administrators or whoever run show run and just start looking through the config. Okay, this is something that a human just shouldn't necessarily go to first, because in your brain it's very hard to unwind all these ACLs and reconstruct sort of the data plane policy of the device in your head to troubleshoot a problem. What you really want to do is use the diagnostic utilities you've got on the ASA to learn more about the problem and not just go to the config and try to understand how it's working. We could use packet traces, we could use capture. All of these things are good, and so we'll walk through some of those steps today. The very first thing I like to do is turn on syslogs. Okay, so the first thing that I'll do here is check my logging config, show run logs. So I've got logging turned on to an inside host, and logging's enabled. I'll say logging buffered debug, because I want to log to the local buffer, and I'll say logging buffer size. Let's just bump it up a little bit. All right, so now I should be able to do show log, and I can see that I've got some messages here. In particular, I can see SYN timeout. Connections are being torn down after 30 seconds due to teardown reason SYN timeout. That means that the three-way handshake for the connection didn't fully come up for this TCP connection. Okay, so we saw a SYN, or we saw the SYN go to the server and a SYN ACK come back, but the final ACK wasn't received from the client. Three-way handshake doesn't come up, so that's why that's the case. And all of these are actually going to our server. That indicates that we're looking at the traffic we might be interested in. A lot of times you'll see logs in your firewall for all different hosts, right? Connections between different endpoints, and you're really troubleshooting one problem. So if I do show log pipe include 10.3.6.50, which is my server, that sort of narrows me down just on that one server. And so I can see here, yeah, it looks like a lot of connections are constantly being built, and then a lot of them are being torn down due to SYN timeout. So we might have a problem. Let's turn on some captures. So I'm going to put a capture on the inside and outside interfaces. I'm going to use the match command, and that will allow me to not have to use an access list to define what to capture. Okay, so I've got my two captures set up. I can do a show capture, and I can see that they're capturing. So let's take a look at the outside capture. Show cap out. okay, this is interesting. So I can see it looks like a lot of different hosts on the internet are connecting to my one server, which is what I would expect. I can see the S flag is here, so that means the SYN flag is set. And then let's take a look at the inside, and it's much the same. So I can see that we've got these SYNs are being sent towards the server, and then in some cases we see a SYN ACK. I know this is a SYN ACK from the server back to the client because we see the SYN flag is set, but also the ACK flag is set here. So this packet made it, the SYN for this connection made it to the server, and then the server responded. You can also zoom in on, say, a particular connection by looking at some value that won't change, like the source port. So I can say show cap in pipe include for, actually it looks like I caught several of them. Let's just use the entire IP address. Show cap in pipe include. Okay, so there's my one packet. So on the outside, we saw the packet move through the firewall. On the inside, we saw the packet move from the inside interface towards the server, but then nothing more. No response from the server. So this is interesting, right? We don't exactly know what's going on here. So next, let's just check. I can do a show con to see what connections are active. And right away, we see some interesting things. So here we see that for the majority of the connections, the flag is SAAB, and that indicates that we saw the initial SYN move through from the outside to the inside towards the server, but then no response. We know that this is from the outside to the inside because we see the capital B flag for inbound. So it's from outside to inside. And yeah, just looking through these cons, it's interesting because we can see that it's all different hosts on the internet connecting to that one server, which could indicate a problem. Another interesting thing is look at the source port. So the source ports look like they're all around 28,000, which that seems impossible that clients all across the internet would use the same source port range, and that's because it is impossible unless they were being natted or something like that. This looks like a denial of service attack, and it's probably not a distributed denial of service attack because most likely they're all generated by one PC or computer or something. The source IP is spoofed, but the source port, the attacker didn't bother to change the source port. So these appear to be, this is a denial of service attack, and the source port's spoofed, and they're trying to use up resources. In particular, you may have caught it before when I ran show log, but if you do show log, let's see if we can find the syslog message. Show log. Let's just look through the logs for severity messages starting at the most severe, and we can see here are some packets denied because those are invalid IP addresses. Nothing for ASA-3, ASA-4. We've got, it's interesting that threat detection's catching some of this, and also here's the kicker, right? Resource cons limit 10,000 reach for the system. So on the ASA platform, the connection count is limited by the license on the ASA 5505. So if I do a show con count, I've got 9992 in use of 10,000. So I'm at the license limit. So there's so many connections built that I've hit the limit, and now legitimate connections are being denied. When I try to reload this web page, I'm probably the 10,001st, or there's probably some large number that are already in place, and so it can't create new cons for me to get to the web server. So to fix this, we can use a feature called SYN Cookies, whereby when the ASA receives a SYN packet from the internet to a server, and we're over some limit set, that the ASA will reply back with the SYN ACK on behalf of the server. Okay, so this, and it doesn't build a connection in the connection table. It just replies back with a SYN ACK, and it encodes a special number in the ACK field so that if the client responds with the ACK to the SYN ACK, then the ASA remembers and knows that the number it's using for that acknowledgement is going to be a legitimate connection. It'll then build the three-way handshake to the inside and it'll build the connection, and that's how it tests to ensure that the client actually exists on that outside interface. So to turn that on, we'll use modular policy framework. The first thing we have to do is create an access list to match the traffic. So we'll say access list SYN ACL permit TCP any host 10. So we'll match just traffic to the web server for now, and we'll say class map ACL SYN class match access list SYN ACL. So our class map's matching. Let's see what service policy we're going to add this to. So we have the global policy added globally, so we can probably just tack it onto that. Show run policy map. And we can see here that this global policy which is applied already has some classes defined. So I'll go ahead and just attach it to that. So what we'll do is we'll say policy map global policy class, put the class name there, and let's do set connection. And we're going, because these are embryonic connections, we'll set a maximum of, say, 100 embryonic connections to this web server. And this number you would tune based on how many legitimate embryonic connections you would expect. So at this point, show run policy map. Let's see if it's working. I've got my global policy here. Here's my SYN class. I can do show service dash policy to see if I'm matching traffic, and it says that I am not. So what's going on? Let's see if it's decreased my con count. At 916, that number's going down. Okay, good, awesome. So it's working. If I do show con at this point, I've only got 115 in use, and we can see here that all of them are AB, meaning that we saw the SYN go through, the SYNAC came back, and we're waiting for the outside client. And I bet if I hit refresh here, yep, I can load the web page just fine. So previously, we saw that the flags were SAAB, meaning that the SYN made it through from the outside to the inside, but we never saw a response from the web server. That's probably because the web server was overloaded, so it couldn't actually respond back to those requests. But at this point, it looks like this is working. Let's clear our logs and look at them again, and we can see that every time these outside hosts, these spoof packets are coming in, they're matching our policy, and we're logging a syslog indicating that we've hit the limit, but SYN cookies are enabled, right? And so for that reason, access will work for legitimate hosts. Is there a downside to turning on SYN cookies? Possibly. It makes troubleshooting more complicated, right? Because it's harder to trace a packet flow through the box when the ASA is responding to the SYNAC on behalf of the inside server. Other than that, it does, reduce system resources because you don't hold a connection open. So this is a feature that you might consider if you are hosting services inside the ASA that you expect might come under attack. But be just careful about how you tune those parameters so that you don't inadvertently cause a problem like throttle them down too low, for instance. So that's it. We can probably see some of the drops. Yep. Resource manager con limit is our drop reason, and that number is probably not incrementing. Yeah, if I keep running this, it's not incrementing. So we've solved the problem. And I can just verify that by hitting refresh again. Okay, so that was it. The root cause of the problem was a spoofed denial of service attack on the outside, and because the source IP was spoofed, we implemented SYN cookies on the ASA. Show run. Let's just look at the end of show run to see how that was implemented. And this is the embryonic con max command is what we use to enable that policy for that specific traffic. All right, till next time, thanks.